Tool has understood that at very top level what is there? TB is there. Below TB, what is there? DUT. What is DUT actually? Design and test. What exactly is design and test? It's half adder. Name of the half adder is DUT. And below DUT, what is there? Two assigned statements are there. You remember the Verilog code I developed using assigned statements, the data flow modeling I said? This process where tool came up with the structure is called as elaboration. Simple elaboration, it didn't give that this was the structure. It only know that there is a DB, there is a DUT. When we did elaboration, it has done this connection. Once it knows the structure, now I can run this simulation. Run hyphen. Is it behaving correctly? I will copy it. Is it correct? Which line number is correct or which line number is wrong? First one is correct, yes. Second one? Wrong. Third one is also wrong. Right? So where do you think is the mistake? Is the mistake with sum or is the mistake with care? Right? So this process is called as debugging. What we are now doing is called as debugging. We are checking the outputs, whether outputs are coming as per my expectation or not. Is it coming as per your expectation? No. So now we are doing debugging. Okay. This is called as finding the issue. We have found the issue. Okay. Then let's analyze the issue. Where is the mistake is coming? Now if I go to the code, do you know where is the issue? Okay. Now tell me, will you debug sum or will you debug carry? So that is what is important. You should not debug a place where there is no issue. You should debug only the place where the issue is present. So you should debug line number 8, not the line number 7. That is important because if you start debugging everything, there will be thousands of lines. You don't know. You can't check everything. So you can clearly see that there is an issue. What is the mistake? This is called as fix. What we did now is called as a fix. Issue happened because there is some mistake in the code. So debugging is a process of identifying what is causing the mistake. What is debugging? The process of identifying what is causing the mistake, things to go wrong. Then what we did now is called as a fix. We are fixing. Then once you fix it, then you again run this process. See, we have to run these steps again, right? Do you have to run line number 3 again? Not required. So only these steps I have to run again. So what I'm going to do is, I'm going to copy them. I create one file called as run.do. Then I can run this. So to run this, do run.do. So what is the advantage or benefit of doing this is I don't have to run each step. I can put together multiple steps and do this. Now is it behaving correctly? You can see carry is coming 0, last one. It is coming proper. Okay. This is like this process. What now I did is called verifying the fix. You found the issue. You did the update to fix the code. Now you are verifying whether that fix is working fine. Any questions so far? Half adder can be developed in 3 styles. One is data flow, one is behavioral, one is structural. We have done data flow. Let us now do structure. How does structural look like? Structural means in terms of gates, how does it look like? One XOR gate, one AND gate. Very simple. Either use gate or structure. I'll do for 15 minutes and we'll end the session. Is that fine with everyone? When I don't instead of going for a break, we'll end the session after 15 minutes. Is that fine with everyone? Okay. So the difference in gate level is very simple. XOR. Instead of writing assigned statement, you use the gates directly. XOR gate and AND gate. The standard convention is, the rule is that output first, input second. That's the rule. You cannot write like this. If you ask, can I write like this? Wrong. Because tool always assumes that first one is the outputs, remaining things are the inputs. Any questions so far? Clear, right? Now, when I have to run this in my test page, do I need to change these things? Nothing will change. Only thing I have to change is only the file name I need to change. Because when I change this file name, what is happening is when I'm saying include half adder gate, I'm asking to my tool, I'm telling to my model sim tool that use this definition. Don't use the other definition. I'm telling that since you are verifying a half adder gate level code, use this definition. That's one. I can now run it. Is it coming fine? It's coming fine if you can notice. Anyone has questions till this point? Okay. How do I confirm that it's actually running gate level? What is there below the DUT now? XOR and OR. Earlier what was there? Assign. So it has now picked which definition? Gate level definition has picked. Clear? Now what is the third step that is pending? Behavioral. Behavioral means using always means. Remember, data flow means assign. Behavioral means always. Structural means using gates. Gates are some other existing structures. Let's write down what is what. Behavioral means what? Use always. Data flow means assign. Structural means gates are existing modules. Already whatever modules you develop, you have used them to develop the bigger one. There is also a programming style, developing coding style, where you can mix them. Some part of the code can be behavioral. Some part of the code can be structural. See, for example, for this building, structural modeling would mean already room structure is there. Just bring the room structure and keep it. Somewhere else, room structure is already given. You just bring the room structure and paste it. That is called as structure. What is meant by gate level is develop everything from the gates. What is the behavioral means? You tell this is the building, 4 floors. This you give it as input to the tool, it will convert everything to whatever you want. Okay. Anyway, so till now I hope you have understood what is data flow, what is structure. Now let's do behavioral. So what is the requirement of behavioral? You have to use all this. So half adder behave dot. I'll copy the same code. When you go to behavioral, will it change? All right. There will still be 2 inputs. There will still be 2 outputs. This will also be same. Only one thing you'll notice going forward is that you have to use a wrench. Behavioral style of coding. You have to use the wrench. This won't be there. You have to use which keyword? Always. At the rate of star. Has it been done in the lab? See? Always. And again, okay, fine. Always at the rate of star. What do you do? A is equal to A XOR B. C equal to A and B. You may say, I don't see any differences. It still looks like a data flow. That is how it is. For simple design, you won't see any difference. For half adder, for full adder, you will not see any differences. For a bigger designs, you will see the difference between what is data flow, what is structural and all that. For simple designs like half adder, multiplexer, you will see both of them are same only, look same. That is how it is. Because and is and only, right? So you cannot change it to something else. So hence you won't see much difference. We can run this code also. What is that I have to do to run this code? It's double slash called as what? Comment. I'm commenting this line. Okay. This behave. Now if I run it. So it's still working fine. So how do I confirm that it's actually running behavioral? I have to go to Sept tab. See now DB, below DB what you have? Below that what you have? Unless that means it's a behavioral style of code execution. Clear till this one? Okay. This completes half adder for us. Now we'll do full adder and probably then with the fill end session. Is everyone fine? Are you okay to do full adder now? Okay. Talking about full adder. What all inputs are there? A, B, C, E, some come C. Because I don't want to use C. Can I use like this? Is it fine? What is the problem? Both will become CC, so I should not use. I should have some way to differentiate them, right? That is where carry in is CI, carry out is C. What do we do? Include A, B, CI. Output S, C. What is the first thing we wanted to do? Data flows, right? In data flow, what is that we do? Assign. S equal to what? Tell me what is the sum equation? You write first a simple expression AB, R, BC, R, CA. This is the one, right? So is this expression correct? I mean, for writing on a paper it's correct, but when it comes to syntax, it's A and B and C and. Just to make sure that the violation don't happen. Understood the point what I'm trying to do? First I want to make sure that A and B happens, B and C happens, then C and A, then all of them should get R. Otherwise what might happen if I don't give this? These two and then R will happen, which may give me wrong result. You're getting? So I don't want that to happen. So hence I'm using brackets. What is this relates to? I mean, where do you learn this kind of rules? Mathematics, right? In board mastery, to bypass all that we use brackets. Brackets will first, but then everything will. Here also same. Clear to you? Now, once you have developed this code, again, what is that? You want to run the simulation, develop a test bench, and run the simulation to check that this code is actually correct. So for that, what am I going to do? Test bench full adder.v. I'm going to develop test bench full adder.v. What is the first thing I do? Include, because I need to know the definition. Now you may say, what is the why? What happens if you don't? Let's say right now I'm including full adder.v. Without including if I run, what will happen is, I'll explain. See, my Questa simulator knows the meaning of module. If I don't have these lines, it knows the meaning of module. It knows the meaning of wrench. Why it knows? But what about half adder? It doesn't know what is half adder. You and I know. Why we know? Because we have studied in the digital design or somewhere we have studied. But models never studied half adder. So it doesn't know what exactly is half adder. You have to give the definition of half adder to it before it runs. Let me again explain. Half adder is not a built-in word. Half adder is not a built-in word in models. Like module is a built-in word. It knows what is meant by module. It knows what is meant by wrench. It knows what is meant by wire. Always initial everything it knows. But it doesn't know what is meant by half adder. So we have to do what? We have to include. When you include, the first thing that my model does is it compiles this file. When it compiles that file, it knows the definition of half adder. Then it will understand this. Then it will understand the line. But other than that, it won't understand. Clear? So do you all understand why we are including? We are including because the model sim doesn't have the definition. You need to compile that so that it knows the definition of full adder. Then what do we do? Module, DB, in module. The standard process we follow is copy these lines, paste it here, cut this line, bring it here. Remove module, what is the shortcut to remove module? Delete the word, what is the shortcut? DW. Go to the end of the word. E. Append, what is the shortcut? A, B, and S. This is the process. Now then, whatever inputs are there, change it to one. Wrench, whatever outputs are there, change it to one. This is the standard process we'll follow. Now it may be looking very confusing. Very natural. If you're confusing also, don't worry, it's a natural thing. After 2-3 days, you'll also feel the same. You'll also find it very easy to do. Okay. Next, what is the next thing we do? Apply the inputs. Initial, begin, end. I can copy the same code that we had here. What is it? 12 to line number 12 to 30. Why 18? Copy and paste it. What is the only other input I have to do? See. Tell me how many such combinations I have to give to verify full adder properly? 8 combinations. Let me again repeat. A full adder can have 8 possible combinations, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. There are 8 combinations. So if I start doing everything, my code will become almost 50, 60 lines. That is where we will find a simple way of doing the same thing. We'll find the simple way of doing things. Okay, someone is asking. Can you please explain concept of reg and wire? When you use reg and when you use wire, how in test bench reg variable is declared as wire and wire in design becomes reg. For today's session, it will be 100% explained. For today's session, let's not get into it. Maybe in a session or two, maybe tomorrow or next session, we'll explain it because I don't want to deviate from simple combination logic coding. Because to explain what is reg, again I have to explain hardware connections. There are two types of connections. One is reg, one is continuous reg. So it will deviate the topic. For today, please ignore this. Okay, Prabal, same thing to you. For today, please ignore it. In the next session, so we'll discuss why we are using why we are using reg, all that. Why? What is the reason? Because I don't want to deviate. My purpose is simple. By 1 week, we should complete all 50 combinations. If I ask you to develop decoder, Verilog, you should be able to develop test bench. Then once you reach that position, then it's very easy for us to understand what is wire, what is reg. So instead of repeating these lines, we are going to do it in a little better manner. Repeat 10 times. 10 times repeat the process. Can I keep 1, 1, 1? Then what is the problem? All 10 times 1, 1, 1 only will apply. Are you verifying anything new there? No, right? Is there any use of that code? No. If I apply only 1, 1, 1 every time, 10 times, there is no use of it. That is where Verilog gives a concept called as $random. Because of that, what will happen? A and A, B, C will get random values. Because I am running 10 combinations, there is a good chance that most of my combinations will get covered. You may say, what if some combination is not covered? Tomorrow when I run in a different random pattern, it will cover. That's the assumption. I probably this repeat 10 won't cover all 8 combinations probably. But next time when I run, it may generate a new combination, also missing combination. If I do this, you may say, what is the advantage of doing it? You can delete all these combinations. My code will get very reduced. You see the advantage? Number of lines gets reduced just by using repeat. You're repeating something 10 times and you're not applying fixed values. You're giving random values. Randomly A will get either 1 or 0. B will get either 1 or 0. So what is missing here? C is A, percentage B. CO. This is how the question. So I can run this. To run this, I'll go to run.2. I don't need to change this because my topmost module name is what? Here also, what is the name of the topmost module? You agree, right? Tell me. In my table example, which is the topmost entity? Is the table is the topmost entity or laptop? Table. Because laptop is sitting into the table. Top means not in the vertical position. Who is containing who? Inside the table, laptop is present. Inside the table, laptop is present. Right? On the table, laptop is present. So my table becomes the top. Below that, laptop is present. Same way, among two things, full adder and test bench. Who is the top? Test bench is the top. Below test bench, full adder is present. Tell me who is the top? TV, test bench. So I have to elaborate the test bench. Okay. You understood? Okay. Now I can run this. There's a problem C, line number 6. Line number 6. Where? In full adder. That is in the full adder. What is the mistake here? How do you see I? Now, let's check whether it is behaving properly like a full adder. Line number 75. Is it behaving like full adder? A is 0, B is 0, B is 1, and C is 1. So 1, 0 will be the output, 2 will be the output, right? So you convert to, what is it? 1, 0. Carry will be 1, sum will be 0. Everyone clear with this? Line number 76. All are 1s, right? A is 1, B is 1, C is 1. So sum and carry will be 1, 1. Is that correct? Yes. You take any one of them. Is it correct? Line number 82. Correct, right? So you will see that it's correct because we use the right equations. We have used the right Boolean expressions. That is where again comes the concept of bug. If someone has done a mistake while coding, I've done a mistake. Let's say here instead of it, I've used target. Is it correct now? It will go wrong, right? This process of identifying. See, here it's easy. If I show you this code, it's very easy to identify, right? I'll give you this code and tell me find the issue. Can you find? Right? Looking at the code itself, we can tell. But I'll go to some other place, let's say. Let's say somewhere here, target is there. Find mistake. Somewhere here. Now I just mixed all the code. Now tell me where is the mistake. Tell me which line number is the mistake. So you don't know, right? You don't know the mistake. So for a simple designs like full adder, half adder, multiplexer, you can tell easily that there is a mistake. Now if I show you this code is not working fine, where will you tell? Is the mistake here? Is the mistake here? Is the mistake in this if condition? Hence, you cannot see the code and tell this is correct, this is wrong. You cannot tell that. That is where you need a proper process. That process is what? Generate inputs, apply inputs, get the outputs, check whether outputs are coming as per your expectation or not. If they come, good. If they don't come, then debug. In half adder debugging was very easy and straightforward. Here, it will be very difficult. Okay. It won't be like half adder everywhere. It will be much more complex. You can see this, and it needs to understand each meaning. What is meant by this? What is meant by this? What is meant by this? Only then you will be able to do some debugging, right? That is the. Okay. So you understood, right? So that is where the functional verification gets complex. Everyone does the same, but what we are doing today, even a very high experienced person also does the same thing. Only thing is, the design he works and the kind of inputs he has to apply and the way he has to check will be more complex than what we do. So in your case, you are going to reach that state gradually, where you are going to learn simple designs now. After a month or two, you are going to learn a little more complex designs. Towards the end of the course, you are going to learn even bigger complex designs. Then when you transition to industry, things could be more complex. Okay, fine. Now have you understood? If I run this code, you will surely get the issue. Then you have to identify where is it went wrong. So you will see that again the same observation you will make, that sum is coming correctly, carry has a mistake. You will see in the pattern. Then you will come into this debug. Then like find even analyze, you will figure this. This is full adder. What style of coding? Data flow. Let us do now structural. You want to continue? You want to continue is fine. Another 5 minutes. Ladder 8. It is very simple. I'll tell you how simple is it. One of A comma B comma C is sum. Is that line clear? Simple, right? But when it comes to this one, is there any one gate which will give you this behavior? How many gates do you require? 4 gates you require, right? So what we are going to do is we will remember that format. A full adder, gate level, gate adder. Which is the diagram? Is this the one? No, right? This is a little different. This is a little different. Okay. So you have got 2 AND gates. So what I'm going to do is AND gate. Output of the first AND gate is what? N1, A comma B. I'll draw the diagram also. N2, B comma C, and N3, C comma A. Then all of them are what? Or C out equal to N1 comma N2 comma N3. So let me draw this diagram so that it's easy for you to understand. I'm only writing for carry out, okay? Not for sum. First you have got AND gate, AND gate, AND gate. All these AND gates are going to one OR gate. What are these? A, B, B, C, A, C. Verilog has a limitation where there is no one single gate X. There is no one single gate which gives you AND OR behavior. You have to implement. Sorry. So by doing that, what am I doing is I'm naming it as N1, net 1, N2. Because other things have a name. This is C out. Other than those 3 wires, wherever I have given name N1, N2, N3, everyone else has a name. What is the name of this wire? A. What is the name of this wire? B. You see on the left hand side, all the inputs of AND gates have the names. But who don't have the names? This doesn't have names, this doesn't have names, this doesn't have names. So we are giving a name to them. Now you may ask, why are you giving N1, N2, N3? Why not give P1, P2? One, you can use it. General convention is to use N1, N2, N3 because they are called as nets. This is called as a net. So hence we use N. So in going by that, this is AND gate. What is the output of AND gate? N1. What are the inputs? A comma B. For next AND gate, what is the output? N2. What are the inputs? B comma C. Next AND gate? N3, C. Which are everything. Understand? N1, N2, N3 are the inputs and output is what? C. Coming to a strange that. Cut out. You may ask why are you not deleting? I can delete also. There's nothing like running it again. Now what is the style of coding I'm running? Gate level description. I'm checking whatever gate level code I have developed. Is it correct or not? So it has given me this output. You can randomly check, it will be correct only. You can confirm here. As much as a DUT, below DUT you have XOR gate, AND gate, AND gate, AND gate, and one OR gate. We will conclude this session with 2 more things. One is called as a behavioral style. Same code I have developed, behavioral style. So let's make full adder. Behave. The easiest way to do behavioral is what? You take data flow, you write always at the rate of star. Star means what? Tell me. Anytime any of the input changes. And just remove assignments. Right now, I am showing you the steps involved in converting a data flow code into behavioral. Let me again do it. Empty file. Pasted what? Data flow. And what did we do? Always rate star. Begin it. Remove the assign. Remove the assign. Then shift by tabs. This becomes behavioral style. The same thing can be done in a little different manner. This is also one more possibility. I will explain this tomorrow. I'll explain that line tomorrow. Don't worry about that right now because you are new to this concept, but you are familiar with this. So hence we'll only stick to what you know. Tomorrow I'll introduce the new thing. So here what is happening is just to give a quick background. If all of them are 1, 1, 1, 1, 1, 1, what is the total addition? 3. In binary, what is it? 1, 1, 1. 3 is 1, 1, right? So lower one will go to sum, carry will go to. That is the result you are expecting, right? When all 3 inputs are 1, 1, 1, sum should be 1, carry out should be 1. Same way if you apply 1, 0, 1. What is the decimal value? 2. 2. In binary, it is what? 1, 0. 0 will go to whom? 1 will go to carrier. So is that correct output? This is another style of developing the full adder going on. You may say, I can go by that. I can delete this. It's also possible. You got it right. Let's say if all of them are 0, 0, 0. What is output? 0. If you expand it is 0, 0. Sum will be 0. Carry out will be 0. Now to check, to confirm this, again what do I do? Change the file name to behave and run it. Okay, because I'm doing behavioral style, output should be rich. For now, just remember it. The only thing you have to remember is inside always, anything on the left hand side should be a rich. What is the guideline you have to remember? Inside the always block, any variable on the left hand side should be a rich. If I run it, it will also behave properly only. I mean, it will come properly only. You can check any one of them, it will come. So let us stop the session here because I don't want to exhaust you with too many things. Why I don't want to do many things is I want you to go home and try these things. Not immediately, maybe 1 hour break you take and you do it. That is the important thing. Okay. The important thing is not attending the sessions. Important thing is once you go home, start practicing. Sometimes you don't know where to start a session. How to type module, how to write input, how to write output. Also, you will find it difficult. That is natural. Everyone faces the difficulty, not you. Everyone faces some level of difficulty. Okay. It's all about overcoming the difficulty. Where you don't understand, you have to come to the trainer and take support. Going home, not doing anything. Tomorrow again coming and attending sessions, no use. If that is your style of study, just discontinue the course and go back home. I'm telling you frankly, that is a style. You don't go home and don't do anything, think that automatically session everything will happen. It's not going to happen. In session, you're only going to learn 25% of the things. Remaining 75% has to happen by your own interest. Only thing is, at times you're stuck. There you have to take this up. Okay, so we'll stop here. So please make sure that you practice these things. We'll end the session. Thank you.
Sure. This conference will now be recorded.